computers anymore, and nobody pays for open source software, but when you say blockchain, suddenly there's a lot of interest. So we hope to generate a lot of interest on that side, and we're determined to get a blockchain product out and see how that goes, but we really want to focus on core Red for the long term. It's it's a small team. We have a few full-time people. Nenad, of course, myself, I've been spending most of the year on project management, getting organized, logistics, figuring out where the business needs to be located so we can coordinate and condense our team. He and our lead developer, Xingtian Ji, have been in China for 4 years working on this, and we have another programmer there whose handle is BitBegin. I don't even know their real name. So we're fairly informal, and we have Tumas Fugled has come on to join us full-time, so he's working for us from Estonia. Lucinda Michelle Knapp is in California, and she's heading up our PR efforts now. She worked for ETH News before that and has freelanced and done a number of things, so she's been great to help us get a lot of this organized, promo materials and t-shirts, and getting continuous updates out, because as developers, we're not very good at that. We focus on the code and we forget, oh, we're supposed to tell people what we're doing. And she's really good about reminding us that we need to do that and turning things like Git commits and progress updates that we see internally into things that other people can hear about. And I don't know how all of you found out about Red. I know one of you found out at least at the DevCon. But it's great to get the word out, and we need to do that. We have Semsenin Moldivi, sorry, from Turkey, who's he's helping us manage and coordinate. He does a lot of community management, and he's helping us part-time right now. Vladimir Vasilyev, Russia, is helping us. He's done an enormous amount of research on the blockchain side, because that was new to us, especially in depth. So he comes from a very academic perspective, and we like to have a lot of variety. I have a background in theater, so of course I'm a software developer. And we'd really like to thank Boleslav Brzozowski, which we know is Bolek, for getting the room set up so we're here and you can all come together, because it's really great to see other Red programmers, reducers in real life. We all live in our isolated parts of the world, although Greg Tewalt, who is another part-timer, has been doing a lot on documentation, actually lives about 30 minutes from me. He came to a code camp where I was presenting and was very surprised to find out that he had found Red independently, and then we live in the same town. Who else do we have?
Lucinda.
I mentioned Lucinda.
Okay.
You never listen to what I say.
Never.
You don't pay attention.
Never.
We spend a lot of time together, so when we banter back and forth, we mostly like each other. But we've spent a lot of time together. In January, we went to a conference in San Francisco for blockchains, and we were together 16 hours a day for 7 days straight, and we didn't kill each other. And he and Xingtian came to the US for 6 weeks while we prepared for the Ethereum DevCon, and we spent a lot of time together. And I think if we were just regular people, maybe we'd hate each other, but we have Red in common, so we unite behind that. I think that's the big thing. We have about 15 people who help us out part-time, and it's great. We have a great community with a lot more people that are deeply involved in using Red and experimenting with it. We have our foundation based in Paris, and Francois Jun heads that up, and he does a lot of work with open computer vision in his lab. Really exciting stuff. Even though it's early days for Red, we're very excited about the possibilities, and we know we have a strong foundation to build on.
You want me to say a few words?
Sure. Just a few. I talk a lot.
I talk even more. So what to add to that? Yeah, for the newcomers, Red is still a small language after 7 years. So usually people say it takes 20 years to get a programming language known and mainstream. We hope to achieve it in less than that. Unfortunately, we will succeed in that. We don't have a big company backing us, like Go has Google behind them, or Rust having a Mozilla Foundation, and so on. So it's a hard work to market the language and to make it known. We are still kind of under the radar, even if a lot of folks on Hacker News know about us, because we publish some articles and they get on the front page each time. So there's some interest there. But for now, that the knowledge and the Red brand is not really well known among the programmers community. still some people know about it in the corners of the world, and sometimes you can just stumble upon a programmer in Thailand, for example, talking about Red, or in other places in the world. So it's we are starting to gain some visibility, but we are still not there. Still a lot of work for that. What else to say? Well, it has been a pretty hard year for us. A lot of work, a lot of work not related to coding tasks, mostly dealing with the crypto space, which is not an easy place to be. We try very hard to be as usual as we are, so very serious about what we do, which is something that does not fit well with the crypto space, which is mostly about hype. So we in the last months, we had quite a lot of issues dealing with that, but we are getting there. We get a bigger team now, so we get people helping us to deal with that. What still amazed me is that the momentum for Red is not stopping. We are not going on the up and downs. We are just slowly but consistently every year just increasing the size of the community. So we have about 50 to 60 contributors now to the GitHub repository, and we have, according to our estimation, about 2,000 to 3,000 people in our community, more or less interested or involved in using Red language. And this, we have 3,500 stars on GitHub now, and it keeps increasing and accelerating every year. So there's a real momentum behind it, even if it's not big, it's consistent. Every year we keep progressing. And that's really very reassuring that we're doing the right thing and going into the right direction. Our project is really not like many other open source programming languages or frameworks for programmers. We have a hard time finding one focus because our solution is very broad. So we have to push it in many different directions. And we do that because it brings a lot of value. Supporting a lot of features that are integrated together in one single tool is something that brings a lot of value to our programmers. So that's something that we are trying to achieve. It's not easy, and that's a very different way to approach things than other projects do. But we believe that's the right way to do it. What else can I say? Well, I think for now that's pretty much it. So we hope that you will enjoy the presentations and the talks. We want it to be quite interactive, so please interrupt us at any time if you have a question. There's not that many people, so we can just make it very informal. Okay.
Do you want to do your
start
with that? Or do you want me to do Lucinda's?
Show me the... just the schedule.
We have Lucinda has been working on a PowerPoint as a very high-level overview that we can hand off to other people. We'll polish it, and then when people have meetups, they could use that as a general introduction to Red and presenting without us. But there's really nothing technical in it, so I don't know if there's a lot of value in that. I can sum it up pretty quickly. It would be great for me to practice it since we haven't done it, although I was just practicing at midnight last night. Should I present this tomorrow? Because that's how developers do. You've got a presentation, you do it 15 minutes before. And we really need to get serious about the marketing side, and that's very difficult because we only want to code. We really want to work on the project. And so it's very hard to pull back and remember we have to do the promotion side as well. But I think we can say that Red is a general purpose language with a lot of features that lets you develop anything, and Nainad, when he explains it here, will go into the technical details. And with the blockchain aspect, we have a new model, because monetizing software is really tough. We have to figure out how to do that, and we talk about it every day. And we have a lot of different plans we can try. We want to try a lot of little experiments and see what gains traction. And when something starts to get some momentum, then we'll put our efforts behind that more. But that's something we'll talk about just as we sit around and drink coffee as well. The blockchain aspect, we had a token distribution event. So we have red tokens that are on the Ethereum blockchain. If you're not familiar with blockchains, it's basically a distributed database, kind of an append-only database, so you put data into it, but you can never take it back out or change it without somebody knowing. And then this is what cryptocurrencies are built on. Bitcoin had its own blockchain. Ethereum is a new blockchain, and a lot of cryptocurrencies and tokens are built on it, and it has the ability to run code on the Ethereum network. And what that means is it turns the world into a global distributed computer. That makes it very slow, and it makes it a very different environment to work in. So we have a lot of experimentation we've done there, but with our own version, it's the red token is not a cryptocurrency, it's what we call a utility token. And with that, we can use it for software licensing, we can write chat apps, so when Bullock gives you a helpful message, you can say, tip him 5 tokens, that was very nice. And we can use it for economics. We can create games where it's used for the in-game economy. So you have a slot machine game or a dice rolling game, roulette, and you can play with red tokens. And then you can use them for other things. And if you, we have Tumas working on our education side. He's developing a lot of great tutorials and examples that you'll see him post on Gitter. And we're going to formalize that more. So you could go through a red tutorial and learn red, and at the end we would reward you with red tokens. And then someone could see, hey, I checked off that they took this tutorial, and that piece of information could also be stored on the blockchain as a reputation system. So somebody else could come in and find out who knows something about the draw dialect, or who knows something about parse, who knows something about a particular feature of Red, or what have they completed. And if employers come in when we eventually start to be used in businesses, they can see who knows different aspects, who's been trained in different areas, who's passed certain tests, and we can try to figure out how the whole, what we call tokenomics system will work. And we'll use these as a fluid piece of information that flows around, and you can collect them, and we don't know if people will spend them or how exactly they'll be used, but that's part of the idea. And one of the first things we'll do early next year, if not before, we hope to do it by now, but everything gets pushed back, is to reward all the people who have contributed to Red so far. So if someone has Git commits on Red and they've contributed to the code base, or they've helped out leading the community, as many of you do here, they will instantly get a deposit of Red tokens. And you can access this via different software wallets, but we'll also give a demo of our Red wallet for the Ethereum blockchain that works with the Ledger Nano and Trezor hardware keys. So you can see kind of how that works, get a sense, because the blockchain is probably new to a couple of you at least. All right, with that, you want to talk about Red itself?
Yeah, actually, I will go pretty quickly. Just an overview of what Red is. Stop me if you have any question about that. So for the other people, I will go pretty quickly about everything you know already. Keep IT simple. This is actually why we built Red, because the first question you might want to ask is, why yet another programming language? We have so many. There's something like 5,000 or 6,000 programming languages in the world. Most of them are not unknown and used only by a few people, usually just one. There's about 1,600 or 700 languages referenced on Wikipedia now. So why yet another one? Well, I've been working in IT and programming since 3 years now, mostly because I love it, like most other people here, I guess. And the problem is that despite the large offer on the market, we are not satisfied with that offer. There's no single language that where we can find all the features that we want and the right mindset behind it. So we want simple. We want to be able to build applications easily. We want to, when you think about, when you create in your mind some kind of application or algorithm, you want to be able to convert that picture you have in your mind on the computer as easily and quickly as possible, bypassing all the boilerplates and all the tools, making the tools efficient to do that. And we don't find that efficiency in pretty much all the mainstream programming languages. So that's one of the main reasons why we are doing that. We want a great programming tool that makes it easy and quick to create new software. So, in order to address that, one of the main points is trying to have one tool instead of having many languages to deal with different aspects of programming. The worst example being the web, where you have 4 or 5 different languages or plus frameworks in order to be able to do anything decent enough. That's quite terrible. And these languages are not related. When you compare HTML to CSS or JavaScript, they are totally syntactically and semantically totally different, living in different worlds. So that's not satisfying. We want to have one tool to be able to address any needs we have in the programming world. So from very low-level programming, so touching the hardware, being able to work with the hardware directly, so even writing or operating a system or drivers directly, up to very high levels, so writing user application, GUI apps, and DSLs, meta DSLs, or any high-level layers, all that in the same tool. We want, of course, to be cross-platform. So for now, we support Mac, Windows, Linux. We don't have the GUI on Linux yet. We have a development branch using GTK as backend, but it's half done. It's not yet ready. We lack resources for that one. We also have an Android prototype version that I can show you on my phone after, which is pretty promising. And we would like to cover more platforms like the web and maybe later iOS. iOS is a very problematic target because it's a very closed environment, very restricted. So it puts a lot of barrier to what we can do, and we are building our own tool chain. So we are not dependent on any library or any existing tool chain, which means that we can't go through Xcode, which is a big showstopper for building iOS apps. So we need to solve that find some ways to solve it.
You answered my question.
Yeah. Another aspect that makes us very different from pretty much everything around in the programming world is we are very DSL oriented. And when we say that, we mean it. Not like DSL in Ruby or DSL in other programming language like Scala, who are claiming that they are doing DSL. We have a very radical approach to that, which includes having a lot of different literal data types. So we have in the base language about 50 data types. That's something you won't find in other languages. And we have about 26 or 27 that have a unique literal syntax. So that gives you a lot of basic building blocks for constructing DSL that you simply don't have in other languages.
For those who don't know, the acronym DSL stands for Domain-Specific Language.
Yeah. So domain-specific languages are really the best tool we can have right now in order to reduce complexity. Because the point of everything we're doing is to reduce the complexity in programming. So there are not many ways to solve that. DSL are a very good way to solve that. We want the language to be simple, which doesn't preclude it from being sophisticated. So actually, we like to often use the lake picture about the language. Mostly when you come to the language from outside, you see just the surface of the lake. But actually, there's a lot of depth there. You will see that in a few slides. We want batteries included solution. But when we say that, we mean it for real, which means that other languages claim or other solution to be battery included. We include the batteries and the factory for building the batteries. and the workers. We go much further than other projects. We also like to be small. Like a famous guy said 20 years ago, 640 kilobytes should be enough for any application. We still follow that direction. So
we are more than 640 kilobytes.
Yeah, currently we are a bit bloated, sorry. So our full tool chain with all the DSL and all the runtime libraries and compilers, interpreters, and interactive console and everything, and the GUI system, it's about still 1 megabyte, so we are sorry about that. We'll try to reduce it in the future versions. We also would like to provide the innovative IDE, mostly oriented towards live coding. So if you know a project called Lighttable, that was created by Chris Granger. We would like to go into that direction and provide the IDE that allows live interaction, because that maps well with the language model we're using. So what we mean by full stack is pretty much that. So we really want to have one tool in order to be able to address all the needs in programming. And we already have people writing operating system. There's a guy writing an operating system from Austria using Red. We have a company in US, in California, who wrote Windows drivers using our solution. We have many people writing applications every day. You can talk here. I think you write some applications that are going in production. I think maybe Rebel also doing something like that. Of course, we are great at scripting. We can do DSL, meta DSL, and address many different spaces. So if you look at the other languages, you know that you can see that they are very different kind of languages. Assembly of C does not look like Ruby or Python at all. They are very different languages, different layer of abstractions. In case of Red, strictly speaking, you cannot have one language that addresses all that. That's technically not feasible. So you need to have, or it will be a huge mess. So we actually use a DSL for that. So we have a language that goes, Red language, the mother language goes down to this, and then we use a DSL to address this. Welcome. Just take a seat. So we use DSL to address this lower layer, and that DSL we call it Red system. So it's basically a C level language that covers pretty much all the features of C plus some extra features that C doesn't have. And the whole runtime of Red is written in that DSL. Well, most of the runtime. Part of the runtime is written in Red itself. So our logo, if you looked at our logo, well, almost this one. Our logo here, it's like a pyramid. Actually, we use the Hanoi Tower since a long time as a representation for our project. Why? Because we build it like a tower with different layers, using different level of languages in order to solve that full stack need. So just to show if how many of you know Python? 1, 2, oh, almost everybody. Okay, so in Python, Python is nice, but if you want to do fast computation in Python or just interface with some external libraries, you have to write Python code, then you need to install a C toolchain, then you need to write a C code, a C library, compile it as a shared library, then write a binding in Python to import it, and then you can use it. In Red, you just write Red code, and inside your Red code you can include, embed Red system code. and both can communicate directly. So you don't have these steps of integrating with some external toolchain. And in our case, it's cross-platform. In case of Python, you write the C code, you generate the library, you need to, if you deploy to different platforms, you need to recompile for every platform. Doing cross-compilation in C, it's still not an easy thing. So you need to install a toolchain on different OSs and then recompile that library, and it's a big mess. Also, in this case, you end up with your Python code plus another compile library if you want to distribute. In case of Red, you end up with one binary. We compile down to one single binary with 0 dependencies. We only, basically in Red, we just use the operating system. We don't rely on any other library. We have a small exception for now. On Linux, we have a dependency on libcurl until 0.7 because we are missing some networking support. So for now, we just rely on that temporarily. In 0.7, we'll just drop that. So yes, we want to cover many platforms. This slide is a bit old, so there may be some things that are not really relevant. We work fine on Raspberry Pi. Android is a prototype. iOS we did not start yet. On the desktop part, we support all that. We have a binding to .NET. We don't compile to .NET VM, to the CLR. Maybe we will in the future. We will see if there's some point in doing that. We might compile at some point to Java bytecode. For now, we just integrate with Java using GNI. And we have a pretty good binding for that, much better than the C1. And at some point, we, like everybody else, we need to target the web. So this slide is a bit old, so at that time we were targeting ASM.js, but now it's WASM. So at some point we will do that. We can do that in different ways. We will see which path is the best for us for that. Yeah, this is how we cross-compile. So if any one of us of you have ever tried to cross-compile using C toolchain or GCC, typically it's really painful. Here you just do red -t, you name a target, and that's all. If you need a different target with different options, you can just, there's a configuration file, you just edit the configuration file and add a different target, specifying different combination of the options, you give it a name and you just use it. It's very straightforward.
To make it completely clear, you don't have to install Red on the other operating systems and use the target from there.
No, it's pure
whatever operating system you're on, you can compile to any other target.
Yeah, from Windows you compile to everything else, from Linux, from Mac you compile to everything else. And all that we're using a 1 megabyte binary. Yeah, sorry, it's bloated. So we have we are really trying to maximize the use of DSLs. So we already have 1, 2, 3, 4, 5. No, this one we did not integrate it yet. I think we are missing one. No.
There's a hidden one that everybody forgets about.
Shape.
Yeah, well, so there's that, but
I always forget about
function spec.
Yeah, there's this function spec. So basically, we have VID is a visual dialect. So it's a dialect we use for. We use dialect in our vocabulary to mean embedded DSL. So it means the DSL that use the same syntax as the mother language. So basically the mother language can load it without any specific tokenizer or lexer. So we have the VID dialect that allows us to specify GUI layouts and connect events to them. So we can, in a few lines of code, create a GUI application. Draw is a 2D vector drawing, basically covering all the drawing features of SVG. So we use the same kind of backend in the OS as SVG. Parse is a very powerful DSL that allows you to parse grammars. So it's a way more powerful option than regex that everybody is using. So since 20 years, we in the previous incarnation of Red called Rebel, we already had this kind of DSL parse that is much more readable and much more totally maintainable, unlike regex. Red System is our very powerful low-level programming language. So all these languages are embedded inside the main language, so you can invoke them at any time. You can combine, compose them, construct the code at runtime without using strings. Schedule is a cron-like job scheduling DSL that we had in the previous Rebel world and that we report at some point in Red. So these are the most of the data types that have a unique visual format, literal syntax. So as you can see, we have things like pairs. We have, here you have the monoline string, and here you have the multi-line string syntax. So we can easily distinguish, no single quote, double quote confusion. We support a lot of date and time formats. So we are compatible with the ISO specification. We support something like, I don't know, 20 or 30 different date formats. We support a Monet format. We have different symbols that we use to represent variables, even if strictly speaking in the language we don't really have variables, but that's the closest thing to that. We even have a special kind of data type for assignment of symbol. We have issues, we have lists, so we have blocks, that is our general container for collection of values. We support tag at first class, files, tuples that we use, we call these tuples. We use them for representing version numbers, IP addresses, RGB colors, or RGBA. Of course, URLs. We call that pass notation. So we use it to express any form of nested structure or data structure.
In other object-oriented languages, you might be used to dot notation, and path notation with slashes is our equivalent.
We have support for binary and emails.
Most of these are one-line examples, but this is actually a single value here from the curly braces to show that with binary values, you can embed extra space and it will ignore it. So you can express things more easily. If you have a big base 64 value, you can do line breaks. It's not just one long string. And what's important about having all these literal values is for many use cases, they have a very specific purpose or a way you'll always use them. So files, for example, you'll say, oh, I know I'm always going to use files to represent files in the file system. But tuples, you pointed out that they can be version numbers, IP addresses, or colors, and it's the same format. And what happens then when you write a domain-specific language, you can say, I want to use a tuple, and it can mean whatever you want within that particular domain. So you can use these values and recognize them when you're creating your language, but not necessarily use them as a file value in your domain. It could mean something else entirely. You can mix and match them for your specific needs.
Yeah, exactly. So these are like Lego bricks. So you have Lego bricks for building DSLs. These are the syntaxes that the language supports. And if you stay into that syntactic space, you get the lexer and tokenizer for free. It's basically just one command. And it makes it then very easy to build DSLs, especially as we use the parse DSL itself for creating DSLs. So we have a DSL for creating DSLs. So this is just an example. Sorry, it's in Chinese, so just one person here can read that. You can read the symbol. So,
Certainly.
yes. So this is just a simple example of how to build a GUI using the VID DSL. So as you can see, it's very declarative. There's no notion of types or function or anything. It's just about expressing in a declarative way what you want to put on the screen. So you just describe the what and how it will be constructed. That's the job of the DSL to take care of that. So just a few information about how it works behind the curtains. Our GUI system below that can be directly accessed. It's a tree of objects, a bit like the DOM on the web, just way simpler than the DOM. It's reactive by default, so you can change any property and it will reflect on the screen immediately. You don't have to call any function. You can defer the updates, but by default it's real time. The reactive part works both ways, so it's a two-way binding. So anything you change on the screen will reflect immediately in the object properties. That's a big, longer example for VID. So we have a lot of features in this DSL. We have the ability to create some styles, conceptually similar to CSS, but the syntax is totally different. So basically you can create like virtual graphic components by inheriting an existing component that can be a native component or another style you created before, and just provide different properties behind it. You can even provide different event handlers, and it will be inherited. And of course, if you enclose, so we have, for example, panels that or groups that provide you scoping, and the styles are scoping aware, so you can define some styles directly into a panel, and they will just be defined there, and you can inherit from the parent scope. So it can be pretty powerful, following the same principle as CSS. So here, for example, we create a bit button using this style, and we name it add, and we declare here a handler. So here we drop down to red code, pure red code. We are out of the DSL. So you have red code embedded. You can embed directly in the DSL. You can also provide here what we call a get word that will refer to a function if you want to externalize all the red code and keep the VID code pure. So for example, here you have the return keyword, which means something totally different than in the regular language. So in this case here, the return means for the layout to go to the next line. So by default, every graphic component that you provide will be aligned horizontally or vertically, depending on the direction you set. And when you specify return, it means return to the next line or return to the next column. And we have, for example, the image graphic component that can take as argument directly an image or a file pointing to an image or a URL referring to an image. So by default, the components are providing you really high-level features to make it really easy and quick to design a GUI. So basically, for prototyping a GUI, it's even faster actually than using a visual graphic designer where you have to drag and drop the components on the screen and then click them and edit a list of options. Because here the system provides you a lot of default options for every graphic component that make it very quick and fast for you to build something. And you can also customize very easily.
Just add something real quick. It is, people ask why we don't have a drag and drop GUI editor, and we have a lot of experiments and examples that go in that direction, and they show that it's very easy. But after you've used Red for a while, the reason we've never put time into building it is because we wouldn't use it ourselves. You get so used to typing it, and it just happens kind of magically from the text. We've never felt a need. For onboarding new people, we've talked a lot about Visual Basic and the appeal that provided to people and for business users to be able to drag things around and create something to show a programmer, I want it to look like this. So we will have tools like that for that purpose. But for most Red programmers, you will probably find that you end up just typing the bit code directly. The point I was going to make is the block here is a default handler. So a button, big button is a button, and that it will handle the default handler is the on-click event, when somebody clicks a button. Every style has its own default event handler. So if you have a list, it will have a different event handler. And you don't have a single, you're not locked into a single handler here. You can use an event name and have multiple handlers. So you can have a keyword called on-click right before that. And then that would assign it to the handler for the click. And then you could also have on-focus, on-unfocus, on-key. Yeah, on-key. So you can have multiple handlers there, or you can define them externally.
So these are a few more examples of the other DSLs. So draw DSLs, for example, this one for 2D graphics. So the thing is that these are all red values, so they're enclosed in a block. So it means that you can easily construct or modify them at runtime. So basically, you provide this block to the draw DSL, you show it on screen, you'll get this, and then programmatically, you will point here, for example, and change this value. And immediately, using the reactive system, the screen will update the result for you. So you can very easily define statically some 2D representation and then dynamically change it using the same representation. This is the parse DSL. So it's the DSL we use for quite often for building other DSLs. It's not a necessity. We could build DSL using the regular language. It's powerful enough for that. But parse make it really faster and easier to do. So basically, parse relies on BNF. Do anyone knows about BNF format? Just, yeah, okay. So BNF format in computer science is used to represent, to formally write the grammars for programming languages or any form of language. So we use the similar syntax as BNF, where you specify the elements you want to match, and here you have so you have rules and you have sub-rules. So sub-rules are enclosed with a block, and you have alternatives. So the type here means this one or the next one. So what you get with that, so you call parse, you pass an input that can be a string or a block of value, and then you provide some rules. And the rules, the goal is to consume the input. If the rules allows you to consume the input until the end, then it returns true. Otherwise, you get a false. So that's the basic behavior of parse. It allows you to validate some input using some rules. But actually, you can do much more than that. There are some keywords that allows you to modify the input, other keyword that allows you to extract part of the input. So this here, yeah, you have here a block of 3 words, and then we provide a rule saying we want 3 words. So by data type, we create a data type rule, and then this should return true. If I remove a word from here, it will return false. So here we have a more complicated, complex case where we want to pass accurately an IP address. So basically you write the rules from top to bottom, from the root to the leaves. So you specify IPv4, that's the name of my rule, and IPv4 is a byte, dot byte, dot byte, dot byte. I really write it like that. So I really start by writing like that. What is the IP address? It's this. And then I will define what are these. So I'm lucky because dot is already a word pointing to the character dot, so I don't have to do anything. Then I need to define what is a byte. So I define the byte using different options. So here it can be the string 2, 5, and then followed by a half. So going from 0 to 5. So half, char set 0 to 5. Then it can be a 2 followed by a 0 to 4, and then any digit. So 0, 4 is here, char set 0 to 4, and then a digit. Well, I could have specified char set 0 to 9, but here, for the sake of the demo, you can combine these char set together, so you don't have to rewrite them using set operations. So you have union, intersection, exclude. You missed one. Difference. So basically, you provide this. If the IP address here in the input matches this, you get a true.
You're going to hate having me in the same room because I keep wanting to jump on.
Yeah.
How many people are familiar with regex, regular expressions? Excellent. Okay. So you might look at this and say, wow, that's verbose. That is so much longer than a regex would be. But there's a reason for that. It's much clearer to normal people. Regexes are kind of like Forth. They're a write-only language. So if you have to debug or figure out what somebody else's regex does, it's really hard. One of the big differences, though, is where we have the ability to nest rules. Regexes don't let you parse recursive structures. So you can't match parens or brackets easily, or at all. There are some ways around that, but it's really difficult, and it can be very, very expensive in the DFA engines, in most regex engines, to make that work at all. So with parse, you can parse really any language you want, any kind of structure and nested structure you want. And when he talked about extracting data, that's like captures in regex. And in regex, you can only capture and reference by number. There might be a couple engines that let you reference things by name. But when you capture something, you can collect it in a variety of ways, because strings and blocks themselves contain other values. Strings are a collection of character values, and blocks can be nested inside blocks. You can collect nested structures, so your captures can also produce nested and structured output.
So red system, basically it looks like this. So this is just an example, maybe not the best one. Oh yeah, this one is the integration between red and red system. So the red system part is here, actually. So it's just for showing that you can easily integrate some red system part into red. Actually, this is red system too. So here you have red, and you can define a special kind of function in red that we call routines. And the routine is the interface between the two worlds, between red and red system. So you can pass red values to the routine, and inside the routine, the body is red system. So you drop down to low-level programming here. So it allows you to, by combining both, to really maximize your productivity. By default, you write using the very high-level language, and when you need some performance or access to some system resources that the main language does not give you, then you drop down at any time into red system, and you can achieve finish your work very easily.
And this is actually as much an example of foreign function interface. So where he's got import, it's now a foreign function interface declaration inside here. But inside this system block, you could have direct red system code and not have to call anything externally. As he talked about earlier with Python and C, you don't have to call out to something in C. You can just write the red system code right here and then call it from red.
So just a side remark, side comment about that. When you look at red source code, so you have a red header. Here we have an empty header. And any red source code must have a red header that starts with the red word, and then a block containing optional number of headers, so just name value pairs, can be options, can be anything you want. We have a standardized convention for these headers, but it pretty much can be anything you want. It's very useful to store the metadata of your source code instead of just putting comments like many people do, because this is something that is passed and can be analyzed by the language interpreter or compiler, or any other tool that will process the source code. Second comment, all this that you are looking at, actually it's not code. Because red language is actually just a data format. So this is all data. So if you don't have any background in Lisp languages, that might sound very weird. I don't know how many of you have touched Lisp. Oh, you do. Oh, okay. So you know about S expressions. You know the concept of code is data in Lisp. So red pushes it even further. So in Lisp, you have the restriction of the S expressions format. In red, you don't have that restriction. So expression can be really anything. And all that is just data. Why? If you load that in red, this will be loaded as a list, a block. This is an issue. This is a block. This is an issue. This is a word. This is a set word. This is a string. And so on. This is a set word. So basically here we have 1, 2, 3, 4, 5, 6, 7, 8 values. And each of these values has a type. It's not code, it's just data. So when that data is passed to the interpreter or to the compiler, then you get the conversion to code. It's not really a conversion actually, it's just interpreting that data as mapping the semantics of the language to that data and producing some computation. But this code is data principle has deep implication in the language and gives open a lot of possibilities that you don't have in other languages. Like, for example, being able to see the source code of a function after creating it live. So you create a function on the console and you can visualize the source code and you can play with the source code of that function. So you can modify the code of the function live, even while the function is working. So self-modifying code is very simple because there's no code, it's self-modifying data.
That doesn't mean we recommend writing self-modifying code.
Yeah, actually we should be putting some barriers there because in some cases it's not something you want. If you use the compiler by default will block you from doing self-modifying code. The interpreter for now allows you to do whatever you want. This is just an example of the schedule DSL. So it's like cron jobs, just readable by normal people and sane programmers. So that's what we mean by DSLs. It's really pushing the limits as far as we can to make it to map the DSL as best as possible to the domain. And this works in Rebel. We did not port it to Red yet.
Actually, I think I did.
Oh, you did?
Something to point out, when you see the hash sign, people call that a hashtag now. We call it an issue used for serial numbers and other things. And what the wide range of literal values gives you is the ability to have the dialect say every 2 days, and we can accept an integer there. But after the word on, we want to specify, and we might also support a direct integer here, but we can specifically say this is an absolute date, not a relative date. And we can use a different data type to help make that clear and make it easier to write the parsher because you're looking for type values. So we're saying we're looking for the word every, and then it could be every day or month, and various other rules looking for words or issues or numbers that make it easier to write the dialect for your domain and use the data types for your own purposes.
So I think I'll finish with this slide. So when we say batteries included, we really mean a lot of things. So basically we have 50 data types by default in the language, covering the 26 or 7 with literal format you've seen, plus some extra others that use something we call a construction syntax. They don't have proper unique syntax, so we use a construction format for that. We have a native GUI system, so a GUI system with a native backend for now. We can plug other kind of backends. We could plug, for example, a text mode backend that will render in a terminal. We could plug a 3D backend. We could plug pretty much anything on that. So collections library, Unicode, we do support Unicode by default. We do it in the same, pretty much the same way as Python does. We have a pretty complete math library. We have a very complete date and time library, hashing, random number generator, very powerful also sorting library. Async.io, it's not yet available. We are working on it in the next. So its next release, next release will be including Async.io 07. We are at 0.64 right now. The protocols, the basic protocols, will also be included in that next release. Parsing DSL, it's there. The interactive console, it's there. We have a CLI, so terminal mode console, and we have a GUI console. The Java bridge is there. Objective-C bridge is there. So it's not merged into the master branch, but if someone needs it, we can provide a branch for that or a pre-built binary with that. CLR bridge, someone did it. It's not included in the master branch for now because nobody asked for it, nobody has a need for it, but someone built a CLR bridge. Compression support, for now we support only crush and deflate algorithm. We will include more of them later. Encryption library, we support basically what the operating system provides. We support set operation. We have a garbage collector in the latest release, and we will include some database, open source popular database drivers in the next releases after we include the Async.io support. So basically MySQL and Postgres is about 40 kilobytes of source code added to the runtime in order to support the full features. Yeah. I probably miss some things because I think that list is a year and a half old, or maybe even 2 years old. So there are probably more features now that we include by default. And all packed, the runtime now is with the GUI support is about 1 megabyte, and it can be compressed. So for example, you can use UPX, and when you compress the runtime using UPX, you end up between 250 and 300 kilobytes. So basically, when we ship compiled application in Red, we ship about 300 kilobytes. Single binary, 0 installation, 0 dependency.
So if you still have a floppy disk laying around, you can fit
Yes.
it all on there.
Yes, we fit on a floppy disk. That should be a good baseline. So I'll stop there for this slide. I would like to show you some more features online, if I can connect to the network.
While you're doing that, let's take a quick break. People can grab a coffee or use the restroom. And
Yeah, if you have any question, please ask about. Yes, not in Chinese, please.
I'm so happy I have an opportunity to use the Chinese, so I'm so nobody uses it.
Yeah, but they won't understand. So
Yeah. Thank you for that opportunity. This was very it's the Objective-C bridge, and I just to imagine what that allows. So that would allow if there is code in the Objective-C to be embedded in the application, right? The 15 Objective-C bridge. If that would be, you mentioned that it's maybe not in the main branch, but if that would be included in the interpreter or the compiler, so I I can use external library that is containing the Objective-C, and it would generate for me executable. That part of the code is Objective-C, and the executable would be Objective-C.
So there are two ways. There are two ways to do the bridging. So it depends on who you want to be the master. So you have two parts, Objective-C and Red. So you can, you might want, and in our cases, in many cases, that's what we want. We want Red to be the master, and Objective-C to be the slave.
Yeah.
So in such case, we have a small library for that allows us to map to the Objective-C objects, instantiate the classes, and call the method directly. So we can communicate, we can import Objective-C libraries and just communicate directly and call them. Red remains the master. That's one option. Second option is to make the Objective-C the master and Red the slave. So in such case, we have the libred version. So you can compile Red, the whole runtime with the interpreter and the GUI system as a library. And that library exposes a C-level interface, API. And that API is all documented. And you can use that API. We provide a few binding for some languages, but I don't think we provided the Objective-C one, but I think the C binding should work with Objective-C. So you can import the libred inside Objective-C, and from Objective-C you can control all the Red features, so you can, invoke the GUI system, you can create Red values, you can manipulate them, you can invoke the parse DSL. So I'll show you an example of that as soon as I connect.
I do want to note there were two people I should call out specifically on the team that I forgot to mention earlier in my excitement. One is Harold Will, who is working in Austria, and he's done some really cool stuff for us. The money data type is coming. It's not in the Lexer yet, but we're doing an experiment. Douglas Crockford of JSON fame has put out a spec a few years ago called DEX64 to be a universal data format, mainly for JavaScript, because JavaScript's numeric handling is not fantastic. He wants not to have floating point errors for dealing with money values, and to have a single numeric type that can work for a language without having to have separate ints and floats and all of that. And there are a lot of issues that may come up with it, but we wanted to try. We wanted to experiment with it. We're not 64-bit yet, so we're limited, but Harold Will has done some great work on that, and we'll be putting that in soon for people to play with. And the other one really is huge. It's Peter Wood, has written thousands and thousands upon thousands of tests for us. He's kind of our testing guru, and without him we wouldn't have all the stability and the ability to add features that we have. So
yeah, we have something like 30,000 unit tests that we run dozens of times every day.
Yeah.
So that's I mean, without that it would be impossible to build that software.
Yeah,
totally impossible.
So it's on camera. Peter, I'm sorry, I forgot you the first time. Okay, let's take a quick break while you get connected.
Yeah, I'm connected actually.
Oh,
so
well,
I don't know if you can see from there. I don't know if you can see the code. So this is hello world here, an example of hello world importing the libred and calling red open here to initialize the library. Then just using red print, creating a red string for this C string. So it will be imported in red and passing it to the red print function, and then just closing. So this is a really very simple example, and this one is doing the same, but with the GUI system. So it's just doing red do. In this case, we just pass a string, but actually you could construct these values dynamically. The libred API gives you all the hooks in order to build these values, so you can compose them, inject C values there, and convert them to red values. And this one will just open a window from C and print this hello world text. So you could, for example, use libred to augment your C application that has no GUI, to augment it with a GUI system for very little cost. So we provide a few bindings. One of the bindings is for Visual Basic, so that you can import libread into Office tools, Word, Excel, PowerPoint, any of them. So this one is an example of importing libread into Excel and writing a short VB code in order to open Excel, so a VB window from Excel, and from that window ask Red to open a similar window and play a little ping-pong game between the two. So this is Red, and this is VB. And VB is the master in this case, and VB controls Red. I can show you the source code for that. It's one page of code, of Visual Basic code. Yeah, it's magic. So this is the source code for that, but I guess it's probably too small. So basically it's that. So all the functions that are prefixed with red are coming from the libread API, and the rest is just VB. So that's pretty much it. So we have some other examples of integration. So in this example, we use Excel. Here we have text. Here we have we wrote a red source code inside this cell. And this red source code, if you recognize, it's the same example as I gave before for the parsing IP address. So we have the rules here for parsing an IP address, and here we have a function, extract addresses, that will collect all the addresses that are matching this IPv4 rule into a block and returning that from that function. So this function, we map it to a VB code, and we put a button, and this button, so we'll call this red function. Oh, it passed. Switch it to another demo. So it calls the need to wait until it finishes. So this is another example where we map the console, create a console in Excel for red. So the button just calls this and process the return values and just display them in this cell from VB. So here I can change the text, modify the content of the text, click extract, and it will update the list using the red code here. So basically, it's like you can build a small IDE if you want from Excel for red, or you just augment Excel using red capabilities to solve some problems you have. So I think this is a quite powerful way. So this might be a bit too complicated for non-programmers still, but maybe we can find ways to provide some higher level tools on top of that to make it, to expose the red abilities to Excel users. So this one is just a simple example using VB. We created a minimum console using two Excel cells. Yeah, for building libread, you just call red build libread because we like simple. By default, libread is compiled using the C ABI. But you can switch to the std call, which is the Windows ABI, by just adding a std call keyword at the end.
We have a number of compilation options in addition to cross-compiling and being able to build libread. We have, Red is a very dynamic language. You can write code that is so dynamic that the compiler can't handle it. It's just, you can create structures that were never intended to be compiled and it can't analyze them enough to compile them. And there are limitations to what the compiler can handle in addition. So we have another option called NCAP. And what that does is it takes your source code and it bundles it inside the exe, but it always interprets it. And you can force that to happen for just parts of your code that are dynamic. So the rest of it does compile to machine code for better speed, but only portions of it will be interpreted. You can force that to work around limitations in the compiler if you come across one of those, or if you write code that's just too dynamic for it to handle. So we give you a lot of different options. Whether you want to run interpreted, you can just have your red files on disk and let people double-click them to run the red interpreter against them. You can compile to EXEs, you can compile libred, you can compile with NCAP mode. We give you a lot of flexibility that way because the needs are so broad and different, or the capabilities are so broad and different. We don't know how everyone will want and need to use it.
So, just want to show you a couple more aspects, and then we'll switch to another talk. I don't know what's on the schedule after that. So, we included about a couple of years ago a reactive system inside Red. It's something that I really wanted since a very long time, way before it became trendy. But we are doing reactivity in a different way than our reactive system. We really want, again, to keep it simple, and basically we want it to boil down to something like an Excel formula. So the way you express relationships in Excel between different cells using a formula, we want to have the same kind of expression level in Red. So we have this kind of special object that we call a reactor. And inside the reactor, some real interesting magic can happen. So you can specify some formulas using is keyword, and then the formula become reactive. So in this case here, in this object, I have x which is equal to 1, y equal to 2, and total is x plus y. What does that mean? It means that once you modify one of these two dependencies, the total value will update in real time, or as soon as possible. So here, in this case, we modify x. So when the object is created, total is 3, 1 plus 2. Then we modify x using the pass syntax to access x inside the object. And we request what's the total. Total is 7. And so on. So this is the basics on reactive system. I don't see how it could be made simpler, easier than that. So we use that to build reactive objects, like the one we're using for the GUI system, but we are not limited to the GUI. They could be used for anything. I think Thomas has a very creative way to use them for parsing rules. You use them once for, what was the... regex. So Thomas implemented regex to parse.
Yes, but it doesn't work now. The system has changed, and
we wrote something. So a regex to parse compiler. And inside his source code, he used a reactor for the rules, right? What did you? What was your use case for reactive formulas inside? I can't remember. It was a year ago.
One way I used it was to invoke, to give it an option to parse it according to different engines, rules of different engines.
Okay. Oh, yeah, I think I remember now. You use it for options, yeah, right? So that if the user, modifies some options, the whole rules that you apply to the regex dynamically change.
Yes.
So that's pretty cool. Pretty cool demo. So let's see a few examples of how to apply it to GUI systems. So here you have an example of VID DSL to specify this GUI. So just 3 sliders and a colored box. And each slider we assign for each one color component, so RGB. And we allow them to go from 0 to 255. So here we have the 3 sliders, RGB, and then we create a base face, which is just an empty face, a box. And we specify the React keyword, and we create a reactive formula. So this reactive formula will link the data property of R, data property of G, and data property of B. So that each time these properties are changing, this formula will be
updated, will be invoked, and the color property of the face here will be updated for you. So it works in real time. Yeah, for comparison, you can add here the non-reactive version of it, so you can see how we reduce the code and make it simpler and avoid repeating the same kind of code patterns. We have more examples here. So this one is just a simple example using dynamic reactive formulas. So formulas you create dynamically, because in the example I gave above, they are statically defined. But sometimes you just want to create on the fly these reactive formulas and pass these formulas, create them from functions actually. So in this case we created dynamically, so there's a loop that is going through every face here, every circle, every disk, sorry, and creating dynamically a reactive formula for every one of them, linking one to the next one. So the position of the next one is the position of the previous one with a little offset, depending on the speed at which you move the first, the red one. This is chain. Yeah, just a chain reaction. So the code for this one, it's not there, but the code for this one, yeah, it's here. It's this. So this is the code. Let me just zoom in. Yeah, so just this. So we use VID to just, we could have created this using a function call, but we wanted to make it visual, so we just statically specify all the balls. So here you see that we use a style for that, and some draw DSL here for filling the ball. And then we just have a loop that will use React link, passing a function as argument for creating these dynamic reactive formulas, and the function, the follow function, just takes two reactive objects, the left and right one, and then we calculate an offset between them, saying that the left one needs to follow the right one. That's pretty much it, and we use, here we store the previous position, so to be able to, next loop, calculate the next one. That's pretty much it.
And we haven't talked about Red being a functional language. It's not a pure functional language,
no.
But functions are first-class data types. When you see the syntax here, using it as a get word, what normally happens when you see a word is it's evaluated. And in Red, when you talk about Lisp being code is data, data is code, in Red we say everything is data until it's evaluated. So when you see a word by default, it will be evaluated. And using a colon in front of it is the reverse of assignment, and that says defer evaluation. So you can get the value without evaluating it at that time. So we've got a function here, and if we didn't have the colon, then the follow function would be called right there, and that would be a problem. What we want to do is pass it so the reactive engine has a function to operate on later.
Yeah, here you have a few examples of how to do math using the time data type. So you can easily extract the seconds, hours, minutes, and just do operation directly on them and calculate new times. The same works with a date. Okay. We have a new comment.
Yeah, I saw it.
So the same works with date. So you have a lot of, you can extract any component of a date or do math on any of these components and calculate new dates, and the system will ensure that it's using a perpetual calendar internally, that the result is a valid date. So you can take the current date and add 100 days, for example, and it will give you the right date.
And there's
including leap years and so on.
We're not limited to whole seconds. There's an extra refinement you can add here, another piece of the path called precise. So if you said /precise, you'd get a higher precision result, whatever the operating system supports.
Yeah, a few GUI demos. So this is using just the draw dialect, using gradient effect, and just animating very simply in a loop. This is just like a gradient lab application, just to play with the gradient parameters to find the right combination that you need. And you can't see it, it's too small, but when you play with these parameters, there's a reactive formula that connects with this area field here, area text, and it generates the draw code live for you. So once you finish, you just copy paste this into your source code and you get this gradient. Yeah, some other variation. Is that your demo, this one? The particle demo? Was that your code, Cypher?
I think so.
It lives on.
You remember that one?
Someone converted it to
yeah, we converted it to Red.
version.
So we are currently using GDI Plus backends for this, for the draw on Windows, but we will be switching to Direct2D. We already have a basic Direct2D support for that, so at some point we'll switch everything to Direct2D. On other platforms, we already use the hardware accelerated APIs. So on Windows, it's a bit slower than on other platforms. So let me show you just a couple, two examples quickly. So this is a very readable code. So I wrote that about a year or so. So it was for posting on Reddit on /tinycode subreddit, and I wanted just to show that in a short amount of code, you can build something that is quite powerful and quite sophisticated, actually. So the expanded version of this code is about 60 lines, and what this code does is basically this. So it creates a spreadsheet, and that spreadsheet allows you to specify formulas, Excel-like, and everything is reactive. So that as you type in a cell, for example here, you modify the quantity, all the dependent cells react instantly as you type. So Excel does not do that for good reasons, for performance reasons. But you can achieve this level of reactivity in a very short amount of code in Red. So basically, a reactive spreadsheet in about 17 lines of compressed code or 60 lines of readable code.
Can you scroll back to the code?
Yeah.
An important note: Red is not white space sensitive in the way that,
or line oriented.
right? Not like Python. We do require spaces between values. Some special characters like brackets will delimit and mark the end or beginning of a value, but you need to use space between values. So you can't, for example, the operators plus, minus, things like that are valid within words. You can use them in identifiers. So you can't condense space around them and have two variables on either side and have it be an operation. It would be seen as a single word. So we allow extra special characters, question mark as well. If you have predicate values, Booleans, what we call logic values, you can put a question mark at the end of that variable name to remember that it should be basically true, false, or this is a question, yes, no. The other thing that makes it really nice, and I remember one of the first things I hit when I was looking at Python many, many years ago, I wanted to copy and paste some code. And I did, and I got it from somewhere where word wrapping had been used. And it wrapped, and of course it didn't work, because Python is very strict about it. With Red, we can take out all the extra white space, so you can condense your code, or you can copy and paste pretty much anything you find online, if it's well-formed, in examples, and paste it right into the REPL and run it. Some things, I don't know if this is well-formed to paste into the REPL. You could run it easily enough, but the REPL itself detects when you start typing square brackets for things that are nested, so it will continue and let you type deep structures even within the REPL. So some code can be, there you go. It does work.
Yeah, it does.
I'm not surprised at all.
It's not fake. So for the last one, let me just see if I can run it live. Showcase. Oops, not working that version. I have a development branch there, so I just okay. So just let's have a look at.
Can I ask a question?
Yeah.
Like how do you handle errors or recursions or stuff like that?
Yeah, we support recursion. We were not. What was the term?
We don't do tail call optimization.
Yeah, tail call optimization. We don't do that for now. We could do that in the future. Actually, doing it in the compiler is pretty easy. Doing it in the interpreter is a bit challenging because it will have a quite important impact on performances. But yeah, it's a feature we could support.
And error handling in general.
Error handling?
Yeah.
Oh, we have basic error handling using exceptions.
Okay.
So you can throw and catch exceptions pretty much anywhere in the code. That's pretty much it. It's nothing special about it. You can capture and.
Well, we have errors will trigger. You can also catch them, their value, so that you can introspect the value itself, the error value, and handle it how you want. We also have a functions called throw and catch, which are not specifically for errors. You can use them however you want. So the main use case is non-local flow control. You're nesting down and you want to be able to throw and go up somewhere else. So you can throw and give it a value, and then up above you can catch and say, I only want to catch this specific thing. So you can catch different values from different parts of your code, which, like self-modifying code or greatly condensing code to the point where it's unreadable, we don't necessarily recommend. But sometimes there are use cases where it's valuable. I think I've used it twice in 20 years for that purpose. But when I needed it, I really needed it.
Let me try again with this older version. Where do you showcase? Oh, it's not there. Ta-da! So using the stable version it works better. So this last code example, I'll show it here, is a port of a demo from the Eve programming language. So you probably haven't heard much about it. It's a programming language created by Chris Granger from Lighttable, and we wanted to port his demo code to Red to see how big it will be or how complex it will be. So basically, it's a clock, but it's a clock you can live edit. So that here you have the source code that is a VID, and here you have inside it you have draw commands for the 2D vector DSL, and here you have red code for the on-time handler. So here using rate 1 means give me a time tick every second. And here we have the on-time handler for that, that will just modify the handles on the clock, handles position, actually the angle, rotation angle.
And so we built this small live coding demo, and we wrote the code for the clock. And as you can see, it's pretty straightforward and simple. You can even express your colors using X format, or you can use the RGB format using tuple, and it's all live. So I can show you now the code for building this kind of live IDE. It's here. So basically, well, pretty much nothing. So here it's the string with the source code that we inject into the editor, and this is for building the editor. So basically it's an area. This is just for the font object that we use there. And then we have the panel here, which is the result. And we create a reactive formula where we make the panel update the view by loading the source code from the text. So we have this area here, which is our editor. And each time we type, we change the content. When we change the content, it updates here. It triggers this reactive formula, and it will load the text, call the VID processor that will generate the tree of faces for it, and connect it to the DOM tree that we use internally, or DOM-like tree. And we just catch errors here in case there's some programming or syntactic error. We don't want to report it, so we just catch it and ignore it. So it won't update in case there's some syntactic errors. That's all. So it's pretty much like, it could be reduced to like 2 or 3 lines. Because the live editor is just relying on the intrinsic properties of the GUI system and the reactive framework. And all that is native, not using any web stack.
Something important to point out with a tool like this, or anytime you have untrusted or unknown data, when we load the code, it's still just data. Loading the data is safe. But if you evaluate something, so if you said do instead of load, that's like eval in JavaScript or other languages that let you execute things that you don't know what they are. That's bad. One of our approaches to security is that you should never just do untrusted code. What you do is you write a DSL that lets people specify very few things, and then you have an interpreter for that DSL so you can execute it. So when that data comes in, it would come in as a string, maybe as a, part of a CGI request or something they typed in. You would parse it to make sure it's valid according to your DSL, which lets you be very secure so you don't have things like SQL injection attacks. And then you would execute it according to your rules. So you could use parse just to validate and make sure they don't have something that's going to format your drive, calling out to some external executable, and then use do on it. But we give you a lot of control about how things are done. Just be sure that you don't think red is magical. So attempt safer down there was just error handling. That wasn't going to prevent code from doing malicious things. So don't just do untrusted code.
So just to add to that, there's an upcoming, in the next release, new DSL that we call the secure DSL. So the secure DSL will allow the programmer to specify some restrictions on both the code and the features of the language that are allowed to run, and sandbox the file system so that you can block the IOs on disk, restrict them to a given folder or list of folders or list of files, and so you can add another layer of security on that. And we probably will extend it also for networking IOs, for example, on some domains or subdomains or IP addresses that will only be allowed to be accessed from that application. So that will be built in the language, and you will be able to specify it from inside the language, I mean the header of the source code, or from command line dynamically. So we do things very differently, as you can see. So maybe there was a question about the error handling. So I guess you were thinking about error handling. I forgot the name of that in Lisp. That has some pretty. What was the name?
Oh, yeah.
A pretty sophisticated system for error handling.
I was just asking because
Oh.
everything was working, so just to see.
Okay.
all happy
What
path
were
code
the
in demos.
Yeah, we have a compiler switch for that. No error.
We do have in our Gitter channels, there's a Lisp room because we do have a lot of people find it because it's a functional language derived from Lisp. We inherit from Lisp 4th and Logo are the primary influences, with some other influences from Scala and Lua. But people have done some really great experiments. Maxim Velesiuk has done the dynamic error handling right out of Lisp.
Yeah.
So if you have Lisp examples and want to port them over, it's pretty easy. Our evaluation model and some of the stuff under the hood, the deeper part of the lake, is quite different, and that will throw people off. You'll get into it and you go, this is great, and then you'll hit something within the first couple of weeks. You go, this is what? And if people haven't taken the time or been indoctrinated to understand that everything is data, they'll go, that's stupid. That is the stupidest thing I've ever seen in a language. Boy, I won't even give this 5 more minutes because that's just a design mistake from day one. And it's not. It's a deeply thought out language. It's just different. So when you hit those, we're around and you can ask and we'll have wiki entries on why do I have to copy series inside functions, stuff like that.
Just about the functional aspect of that, we don't have yet higher order functions built in, but we plan to add them. We have already some good idea about the design for that. But currently, if you want to do higher order functions in Red, it's about a few lines to re-implement the basic ones, so folding and currying and applying everything. Many people have already built their own short library. Greg has one, and I think Vladimir has one.
His is more advanced.
More advanced. So many people have built, because it's like you can rebuild the basic higher order functions in half a page or 1 page of code.
And one of the reasons we don't have them in yet, even though they're just a few lines of code, when you become part of the community, and you're part of the community now, you'll find that suggestions are very welcome. We love suggestions. We love new ideas. But we also push back when we're not quite sure about how something should be done. And we don't want to just incorporate things, this other language has it, so you should have it. No, we couldn't stay small if we did that. But we take a lot of time ourselves thinking about how exactly should this work. And because things are different, if we just took map filter, we already have a word called reduce, so we can't take that, from Lisp and said, oh, they should just work exactly the same. It might not be a good fit for the language as a whole. And we try to look at the big picture when we incorporate things. And that means a lot of pushback and a lot of design work.
We might be a bit slower than other languages for the progress, but we really try to ensure that new features won't break the consistency of the language or won't open some kind of worms somewhere or Pandora box and become something very nasty in the future. So we really try to take small steps in order to do some progress and not just accept any new feature or new contributions, even if it's cool sometimes. But we think that it might be dangerous in some use cases, so we would like to refine and work more on this. So sometimes we can be a bit slow about that, but we love, of course, new ideas. We need feedbacks, new ideas to help us improve the model and make it a better tool for everybody. Any questions?
Did you want to do some live demos, like ballots and stuff?
Yeah, so...
do we need to go get snacks from the supermarket? Yeah, I can do that. I've seen the demos. You go with me. Okay.
Yeah, so just as an example, we've seen, but because we are about since more than a year now also in the blockchain world, and especially we focus on the smart contracts on the Ethereum platform, and we saw a lot of crazy things happening there, like everybody else, but also crazy things at the technical level. So, for example, a few weeks ago on the Viper, have you heard about Viper language? Maybe some of you are part of the Viper communities. No. So on Viper, there was a PR that was sent to the project a month or two ago, about 2 months ago, and the PR was about removing the Unicode support for identifiers. So Viper was constructed to support Unicode. Solidity does not support Unicode in identifiers. Viper was supporting it from the start, and because that was Vitalik's vision. And a guy sent a PR sending that identifier should only be ASCII, because Unicode is too dangerous. Because you could do homomorphic attacks.
Yeah.
But he hasn't proved how to achieve that. He just asserted that you can do this kind of attacks. In theory, yes, you can. But in practice, I don't see how you can do that in any way.
Unicode has subset, safe subset.
Yes, and also there are some safe subset. But anyway, even if you allow the crazy symbols, or you allow the dangerous combinations, I don't see how it can be a vector for an attack in a smart contract. I really don't see. We tried to search and to see how this could be a problem. We could not find a reason for that. And the most terrifying thing was that the PR was accepted immediately. So the guy said, "Oh yeah, good idea. Okay, I accept." Wow, you just changed the language. I mean, a lot of things. I mean, there's a lot of consequences to that. I accept this PR because suddenly the identifiers are only in English instead of being in any language. And you want smart contract to be used worldwide? That's not a good idea. People in China, they like to write in Chinese. People in Russia like to write in Russian. And when you write the smart code contract, you write it for yourself. You write it for your team, you write it for your organization, for your company, for your customers. You don't write it for the rest of the world and using a mandatory English language. So having the identifiers suddenly becoming only ASCII is a big decision. It's not a small decision. And the decision was made like instantly, without any comment, without any discussion. That's not how we do. We don't proceed like that. And I think it's very dangerous to do this kind of thing, and it shows that these kind of projects are not well managed, which is terrifying, because these are critical infrastructure tools that are used by people to handle huge amount of real money. So when we see things like that, we are quite terrified. And a few other things we've seen in the last day at the DevCon also was quite scary from the technical side. So, well, we are older people, and we have also a good background in real business, big Fortune 500 companies and small businesses, so we know what's real life and real businesses. And we want to build things that have value, even if they are not mainstream. We believe this is the right way to do things, and we push into that direction, because we want to have people who are more productive, reduce the cost, maintenance cost, and building cost, and the time to market, and this kind of thing that matters to the real world. Any question about?
I have one.
Sure.
One question, two sub-questions about the garbage collector.
Yeah.
You give a high-level overview. I didn't find that. Maybe I just missed.
Yeah. We are releasing the garbage collector in the master branch now. So it's stable enough. So it should be okay for the next release. So 0.64 should be happening in a couple of weeks, depending on Greg, when Greg is ready for that. So the garbage collector will be in the stable release. Currently, the implementation is very simple. So it uses a basic mark and sweep algorithm, and we use moving collector. I don't know if you are familiar with GC's. So we don't use a copy collector. We use a moving collector. where we basically just compact the memory, so we have zero fragmentation. We have a bit higher cost for the GC collecting paths, but the algorithm optimizes the moves so that we have chunks, big chunks of memory, and the compactor compacts across all these chunks. So we just make one pass. So it's not generational, but it has some generational aspects. So in 0.9 in red, in our roadmap, we plan to implement a more sophisticated algorithm for the GC, and using really generational chunks, groups of chunks of memory, and some incremental aspect to it. Basically, we want the GC to be tunable, so that the user can tune it for different kind of use cases. So if you want, and basically it can boil down to the GC pass time delay. So you can set the delay. You can set it very shortly, like 5 milliseconds or 10 milliseconds, or you can just let it as long as it wants, and then the GC will behave differently. So it can be more adequate for server-side application or more adequate for real-time, like arcade game application. So that's the basics, the basic of what we want to achieve in 0.9. Currently, it's just a stop-the-world basic mark and sweep GC with this moving compactor. That's pretty much it. We want to move to some more sophisticated algorithm on top of that. And one thing, if I find the right person for that, so I would like to find some AI expert to work with us on that. Actually, I think it should be possible, because it's a good use case actually for a small AI, to put an AI on top of that, that will be trained with different kind of situation of memory pressure use cases, and that will learn, so it will optimize a function on that will minimize the memory usage and the GC delays. And once the network, this small network, is properly trained, we can incorporate it into the runtime and the GC, and make it operate the GC, so that it's not up to the user to modify the parameters for the GC, but this small AI network will do the job for you in a better way and real time. So it will adjust all the GC and memory allocator parameters live, depending on the current usage. So are you allocating a lot of small objects, or are you making big allocations space between a few seconds? So the way the current application operates the memory, this small AI will optimize live the parameters to make the GC adjust to that. So that's something that hasn't been done yet in any language I'm aware of. I'm not even sure if anyone is researching on that. If someone is researching, I would be very glad to meet. But if we can find someone that is interested into that, could be a good student in AI, that's something I would like to try.
I think some lists,
is there anyone that...
list is doing this
Really?
I just
because actually, when we start studying that, we really think that it's a very good use case for a small AI and a small network, and it could work fast enough to make the right decision for this parameter in real time.
Is it possible, or will it be possible to question characteristics of garbage collector? For example, I have test, I run some code, and then I question how many memory blocks are left as a garbage.
Yeah, you can interrogate. It's a bit rough right now, but for the release, we'll improve it. You can get some statistics live, so you can get a dispatch of the. You can get a list of. What if I have it in this version? Yeah, so Oops. It doesn't like. So here it's a bit rough. It will be a bit more readable in the release version. So basically here you have the stats about the memory blocks. So here we have some structures that we call node. So there are some intermediary layer that allows us to do the moving, because otherwise when you move, if you have many references to the same memory region, you just cannot update everything. That would be too big work. So we have a little abstraction layer on top of that that allows us to move the main memory areas freely and just having to update one location. And the second block here is a list of the memory chunks that are allocated. So the last element is the size of the chunk. So it's about the first one is 1 megabyte, the second one is 2 megabyte. And the first one should be the free space in bytes, and the second one the used bytes. So free, used, and total in bytes. So you can see that change after GC. I can call the GC. I don't think that will change a lot. Yeah, a little bit. So you can see how the GC releases. Actually, it's just after booting, so there's not much to clean up. Yeah, so for example, here in the second block, it freed about 100 kilobyte, a bit less. 100 kilobyte. On the first block, it freed 7,000 bytes.
So it means it will be possible to program defensively. That I specify that some part of code won't allocate more than some number of blocks or.
You mean from the user having a possibility to limit?
Yes. That I will write test. The test will invoke something, and then I will check that.
There's nothing right now that will make a live check. And that allows you to block in real time. But after executing some code, you can check the memory usage in detail and take some action if you need to. You can do that. But if your question is about having some ways to block, to limit for a given code the memory usage, we don't have that right now. Maybe in the future if we find some good use cases for that. So yes, we don't use much memory, and here we have the GUI console, so it uses more memory. If you run it from the command line, the stats will be much lower. So basically, the runtime should require about 1 to 2 megabytes of RAM to run right now. I think it should be 2, basically, 2 megabytes. Yes?
So apologies for not knowing. Basically, first time I heard about this language was today. I came for DevCon and saw that you guys have an event, and it looked interesting on the website. So, and from what I've seen so far, it really looks like an interesting language. So, I'm interested in what is the crypto angle, like the smart contract aspect of this.
Yeah. So I can cover.
That's good.
Maybe you can show how it looks like.
Yeah.
Key.
Oh, yeah.
Because maybe some people here never seen this kind of. So this one is the ledger key. I guess they are the leader on the market now.
Do you guys want light?
Sure.
And you have also the treasure key. We have a treasure key here with you. Wait a moment. So these are the two main hardware keys on the market. So these keys are used for producing a pair of private public keys. You can produce as many as you want. And the private key stays in the secure element inside the key. So that the computer, even when it's plugged on it, can never access that part of the key. So that's the principle it's working on. So there's a gateway and separation, and there's two microcontrollers inside. One is in the separate part of it and secure, and the other one is just for the USB communication. So your private key stays on the key, never leaves it, ever. So that's the point of this software. And actually, this kind of hardware can be used for, well, the crypto world, generating pairs of keys and signing your transactions, but actually can be used for anything. For example, well, logging on a website, that's totally possible, or signing some file you want to encrypt and storing them somewhere. It's just a generic key that where you can load some application on it from the vendor for different usages. So the main one being the crypto world usage.
Can we turn just these off?
Treasure?
Yeah, that's
Oh, yeah.
the tracer key.
The treasure key, well, this one is the 3D printed version, and I think the treasure key is meant by local production.
Yeah.
Czech technology. And it's open hardware, right? Ledger is not, but this one is open hardware, and this particular version is a 3D printed, very cheap version of it that we use for demos or for development. So the original one is a bit has a better plastic and better, more robust design. This one is just 3D printed.
Which one is better, the Trezor or the Nano?
There are pros and cons. The Nano, I like the Nano hardware, but the problem is the screen. The screen is too small to display a full address. So when you sign, you have to do the review of the amount and the review of the address, and you have to check if the address, the destination address, matches the one that's on your software, on your phone or on the desktop screen. And you really need to be sure that it's the same, because there's no undo option there. Once you sign, it's done. So on the Nano Ledger, the screen is not big enough, so the address will scroll left and right, and that's not very convenient. That's the biggest issue with the Nano Ledger. On the Treasure, it has multi-line display, so the address will be broken over several, spread over several lines, and then it's fixed. It doesn't move, so you can check easily all the symbols to see if it matches. So. But the Treasure key has a design that is less robust, so if you drop it and just step on it, you will destroy it. The Ledger, I can jump on it, nothing will happen.
And then the wallets are inaccessible if I destroy the Treasure?
No. It's you have seed words that you use for producing random seed words that are used for producing the pair of private and.
So if I use Trezor and I can.
Yes. The hardware does not matter. What matters is the seed word that you use for creating this pair. They are randomly selected by the key at the beginning when you run it the first time or when you reset it. And so you have to write down these seed words somewhere in a secure place.
But not too secure.
Not too secure, like Greg, because when you need it, then it's very painful to get them.
Or if you lose them, all your funds are locked forever.
I just only have the software wallet of the hardware.
Yeah. So it's, the principle is the same as the software wallet. You have this list of words. You need to save them in a safe place, and then you can use them to reset the key. In case you lose your key or your key is destroyed, you can buy a new one and just use the reset mode. You input all the words, and you get back all your keys.
All right. Did everybody see it download?
No, it's too fast. You cannot see
wait.
it.
All right, we'll do it again. Ready? Don't blink. Done.
Oh.
Because it really is about 300K. And then you run it, and it comes up, and there's no device detected yet because I haven't logged in. So as soon as you plug it in, it'll power up, and then you have to enter your secret passphrase.
Usually that's
Well,
the application crashes.
It always starts from different numbers, so if we just look what he's doing with his fingers, we cannot...
For example, you can try to count how many times it will use left and right.
Yeah, but it doesn't start from 0, it starts from random number.
It used to start from 0 until 3 or 4 months ago, where they made an update to fix that, because that was, yeah.
Okay, now I'm ready.
Maybe you need you can reduce the background file manager window to make it more visible.
And you can have multiple wallets for different types of currency on the Ledger Nano. So you can have a Bitcoin app, an Ethereum app, Zcoin, Zcash.
Where's all our money?
Oh no! Where's all our money is gone. You'll note that there are big yellow things all over this with warnings that it's a demo. So you can choose the different networks you want to connect to. And so what it did now, as soon as I logged in, it detected that it was a Ledger Nano. It would tell you what type of hardware device you connected. And then it will show you the addresses. And the addressing scheme, for those of you not familiar, is called hierarchical deterministic derivation path. And there are all sorts of fancy numbers they hide in there to make it even harder to understand what's going on, and they're not all compatible. But you can keep generating more and more addresses. So, for example, if we use this first address in the list for all our funds, and then we have transactions on the blockchain, everybody could see where all our money was and where it went in and out, other addresses it went to. So you might use an address, that you never use for anything else for transfers you want to keep a little more secret. And that lets you select if you want to use ETH or RED tokens in your transaction, and what network you want to be on. Mainnet is the real deal. That's where the real value is for Ether, and then you have a few different test networks. So we'll see, do we have anything on Rinkeby? Look, we've got some on Rinkeby. So now I can select this address. I'll copy it. And we see it starts with C467, ends with B6C3, and I won't remember those. Sometimes you'll look at just the first few and last few letters, and I'll look for repeated patterns. So you might see a number of Fs or a number of 6s or a number of any character in the middle to help me identify as it scrolls back and forth, because it's really hard to verify. And then you say send, and the one it's sending from is the one that was selected. Oh, that's the one I don't want that. I copied it, but I want to actually send from this one. So the highlighted address is what you're sending from. That shows up here, and you can verify that the same thing shows up here, that we're not hacking and trying to change your addresses on you. How much ETH do I want to send? Let's send 1. We won't go into gas prices and gas limits, but I'll increase them a little bit here, since sometimes they don't want to work.
No, gas limit should be okay.
Oh, sure, it should be. On the test network, maybe. And then when I say sign, it's going to tell me to confirm the transaction on my key. Now what's come up here is the amount. It says ETH1, 0xC46. There were some 3s in there, and then 1591, B6C3. Yeah, that all looks right. And
can you turn on your camera on your?
I've got it in secure mode.
Oh.
I don't want to turn on my camera while I'm working with my ledger.
No, so you can show the screen of the ledger on the big screen.
You can come up and look after if you really want to see it. And then you only have 2 buttons to do all these operations. You have, and in this case, you have a cancel and a check. And I want to say check, because that's where we are. And then it comes up with a verification screen to make sure, once again, that we've got it all right. So we can confirm our addresses against what's in the screen, the one we know we were sending to. And we want to add more features here, so you can have a secure local list of people you want to resend to on a regular basis. We may do the blockies thing like the other wallets do to show some kind of graphic that relates to them, but we want to do even better than that. So this confirms all our information, and then I say send. And when we do an individual send, it will pop up the transaction on the network that you're sending to. So in this case, we're on Rinkeby. on Etherscan so it can see the transaction. It was pending. I gave it a good gas price. Success. So now when I go back here, we have to reload to get the information again. It doesn't automatically refresh. It doesn't keep polling. So now we should see our top address go from 29 to 28, and our third address go to 1. You'll see the top address will incur a little extra cost. The sending address is the one who pays the gas fees. So if I send you 1, you get 1. We don't agree that I'm going to send you 1, and you go, I only got 0.999962. What's going on? And there we go. We have a batch payment feature, which most other wallets don't. Oh, I ran from a different location here. Somewhere I had, well, we'll show how this works creating one. So I can add a new entry. Wait, call it LN3 because it's the third address on this Ledger Nano. So I still have my address in there. I'll send in 1. We'll just do the 1 for now. So I can add more or edit them in this list, and then I can save them. And then I can do a send. And now, for every transaction that's in this list, it's going to show me in succession. So I confirm this one. And if I had more, it would just keep asking me for each one until they were done. And the little check mark appeared to show that it was successful. A little X would appear if it wasn't. This saves a lot of time because we're using ETH with some of our people now, and with other wallets, or before we had the batch feature, you have to go back and forth to the software, to the hardware, to the software, to the hardware. And this way I can set them all up, and I can easily go in and just edit amounts if they change every month. But still have the addresses in the list that I trust pretty much, and then I can just click through on my ledger. And if I want to see the results, then it will open the browser just like it did before. And when it comes up, it's clear, but then I should be able to import . Oh, maybe not. Didn't take it. I know Qingtian changed that recently. So now if I go back here, I should have 2 in my third address that I just sent to, and 27 in my first address. I love it when things work. Down here you can go to pages of your address, or you can just go through more. The Trezor works exactly the same. There's no difference in the interface standpoint. It's only a slightly different interaction on your device.
So this wallet is really a bare-bone wallet. It's just the raw core features that you expect from a wallet. There are tons and tons of features that we can add on that to make it way more usable and nicer and better. For now, we are just focusing on the core features, and we'll see for the next different release. It's still alpha. It's alpha 2, this version. We'll see on which direction to go, because well, we can choose many different directions, and we are not yet sure which one is the best. For example, instead of displaying addresses, we could just allow you to set labels for each address to make it easier to manage. Then the problems become where to store it. If you store this information on your hard drive, well, first it's not convenient, because when you move to
you plug it on a different computer, you don't have it. Then second problem, it's visible. Someone can have a look at it. Then he knows which address you're using for what. That's not great. We could encrypt it. It provides a higher level, but well, still, we're not sure if that's the best way. Another option could be, for example, to store it on the chain in a smart contract, maybe. That's only for you. Or maybe store it on IPFS and encrypt it on IPFS using the same key, so that only that key can decrypt it. There are many different options where we did not choose yet which one is the best.
You'd have to encrypt it on the chain too.
Yes, on the chain anyway you have to encrypt it too. And one of the features we wanted to have in that, that's why we are trying to dig deeper into that, that feature is being able to share some contact addresses with others, or having some common list of addresses, like in an organization, having some common wallet, a multi-sig wallet or others, and sharing that list with other wallet users. So that's why we're thinking maybe a smart contract will be good for coordinating that and maybe storing on IPFS.
Something that came up while we were developing it was how to ensure that the wallet hadn't been hacked. How do you know that you're not getting a malicious version of our wallet that somebody had compromised somehow? Because they can make things look exactly the same. And that's really hard. The client can always be compromised. So we provide a service. We provide a page that has the hashes of every official wallet release we make.
So it's just a hash check, but instead of having to download the tool, hash your file and compare, we just provide a web page where you drag and drop your binary, and the code will, the JavaScript code will just do the hashing for you and compare with the server-side version and tell you if it's okay or not okay.
Did anybody do something like this before?
I haven't seen anybody do that.
Yeah, but their files are too big for that.
The hashing is done locally.
So they could.
You don't.
In theory, they could. And we can also put these hashes on the blockchain itself. So if we just drag some random file over here and see what it says. So in this case, you're still trusting our server, but you're
actually you're trusting GitHub, because we put it on
That's
purpose.
Right. Yeah.
We put it on GitHub and not on our servers, so that people can trust it more. Because they can access the source code actually of these GitHub pages and check what is it doing.
And it also shows you, in this case, this is version 0.1. That's an older version of the wallet. Because it knows the hash, it can tell you the exact version of the wallet that you have. Which could also make it easier for support. What version of our software are you running? I don't know. Drop it on this page. Oh, 2.1.
And we have a long list of features we would like to build to add to this wallet, including some helps for the target address. One of the main issues when doing this kind of transaction is that to be sure that the target address you are sending to is the right one. It's the right person, or is the right organization I want to send my money to. And that's pretty often complicated to, I mean, you have to triple check or quadruple check everything all the time. I guess we all do the same thing when we have to make a transaction that's a bit significant, and that's really painful. So there's no currently on the Ethereum blockchain any mechanism that can help you with that. You can just make one mistake, like remove a character. Well, we can check for that, but change one character in the address and your money will be lost forever if there's no one on the other side. Yeah, it can be as bad as that. So you really, really need to be 100% sure that the address that you're sending to is the correct one. So we were working on many ideas for that, like doing fingerprinting with microtransactions, so that when you have a new target address, we will send the wallet will automatically send on first use a very small amount of ETH in order to validate that address and waiting for the reply, because that's how you usually do on Ethereum in order to be sure that the target address is the right one. You contact the person and you say, okay, I will send you a very small amount, and you tell me, or you send me back that amount when it's right. And you just confirm offline or during online with that person that is the right thing. Then you double check again everything, and then you can send your amount. So we want just to automate that process. So if two people are using our wallet, we could make that pretty much automatic on first use, and then once that address is trusted, we can add it to our contact list of addresses. So we did not yet decide where to put that contact list in order to make it safe. So probably somewhere online in encrypted form.
I'll just talk quickly about some ideas I jotted down. We talk a lot, especially late at night, and come up with ideas. And then if we forget to write them down, the next day you go, what was that really brilliant idea we had? We had solved this problem, and then in the morning it's gone. So we try to make notes even late at night. The cron system, because as we noted, the Ethereum virtual machine can't trigger anything internally. Everything has to come from outside. So how do you have a cron system that could trigger things? And it's difficult. There are a number of ways we could do it. One, we could have a vetted binary, much like our wallet works. We can have a binary that we give the user, and they could run it locally, and it would be given the schedule. If you include a schedule in your smart contract, in your C3 contract, that can generate the rules for this binary. It could be a config file, or it could actually generate a full binary with those rules encoded inside. So you could drop it anywhere without any external files, and it would run. And we could verify it using the same kind of binary checking we do for the wallet. They could run it locally, or they could run it on a trusted device. They could run it on multiple versions on a cloud service. So they could use AWS and have multiple instances of it running, or have their AWS EC2 instance set to restart in case it crashed and it's the only thing running that. Then the onus is on them to make sure it runs. They're in complete control, but it is on them to make sure that that works. And then you run into the issue that I mentioned about what happens if it gets called multiple times. We have the concept of idempotency. If you call a function more than once, it will only ever return the same result. It won't cause the same action to occur more than once. So calling it more than once can't hurt anything. So you'd have to design all your functions that are called by cron to behave that way. And that, again, would be on the user. It's very hard for us to protect against mistakes on that side. If something shouldn't happen more than once, how do you make sure that it doesn't? And how do you warn them maybe if it's called more than once? So your cron is repetitively kicking it off. That costs the execution gas. So if they're paying for that, they don't want that happening. But if you want to make sure it happens at least once, how do you warn them? So you need a way to get the information back to know if the cron task actually executed. Another possibility would be to have your contract, as in voting is a big example on the blockchain. It's used for voting. You could have multiple tasks, multiple instances of the cron task running, and your contract is set to require a certain number of votes. So every time a trigger occurs, that counts as a vote. And it has to reach a certain number of votes before it executes. So if you don't have a time constraint within your contract function to say it shouldn't execute before this, and somebody says, if I execute it early, I can win. I can steal something because they don't have other checks in place, because they can see all your smart contract code on the blockchain, you could have a voting system put in place where multiple cron callers have to call it before it will go off. And then somebody would have to know about that as well, which if they can see your code, they would. And that's hard to protect against. You could also set it up as a service. So you could put your cron tasks out there and have people bid on running them, because they have to have an external server process running all that time in order to be able to call you when those crons should go off. So you could have a bidding system where somebody says, I'll take this cron task, and for X number of ETH, I will keep my server running until that cron task goes off, or I guarantee I'll call it 50 times just like it says it should be called. And you're going to have to pay me to do that, just like miners get rewarded for mining blocks on the blockchain. There are so many open questions about it. It's kind of daunting to think how we secure it in all the different ways possible. So we can provide a service. That's probably one of the first things we'll do. Make it very easy for you to specify those cron rules in your contract, and we'll provide a service to do that. the vetted binary is the next easiest thing because it puts the control in the hands of the user. And we don't have to solve all the other problems just yet. We need to experiment a lot and find out what's going to work in order to improve the system. So those are some of the early ideas on it, but nothing is set yet because we have a lot of research to do. And with that, I think I can hand off to Bolek if you want to. Did you want to demo something today?
Yeah.
All right.
Great.
Okay. I will talk about values. Values in red, but more specifically about something called values with a big V. What is something I'm working on right now. I will ignore it in just a moment. Okay, so I will start with this picture. This is Visual Studio Code. It's integrated developer environment or IDE, and there are some attempts to write IDE in Rebol and Red. I don't know about some IDE in Red or Rebol that is used by many people. And I can show you why I think there are no IDEs right now. And then I will show you what I think is the right approach to write IDE. So, okay, this is not the best picture, but anyway, if you look at typical IDE, there are some icons, something there. And there is some area where you write code, or maybe some output. This is not output, but imagine that this is output or something. And typically when people try to write IDE in Red or Rebol, they try to mimic this. So they will put some icons there, menus, and typically this area is normal standard text area. So it doesn't have syntax highlighting and things like that. Because people focus too much on the stuff around it, but this is where you spend most of your time. So to have good IDE in Rebol or Red, let's say Red, we must focus on the editing area. As you can see, I'm using Linux, so I can't do either in graphical mode because Linux does not have good support, or Red does not have good support for Linux. So what I can do is doing it in console. It's actually not that bad idea. The editor I'm using most is Vim, that works in console, so it's possible to do editor in console. There is another thing. Red doesn't have ports yet, so there is no console port. So even if I want to do editor in console, I cannot do interactive editor. I cannot do things like navigation with cursor case and stuff like that. So the only thing I can do is line-oriented editor, something like add. I'm not sure if you have seen add. It's a very basic editor from 70s where you write something, press enter, and it's added to the source code tree. Very basic. So the only thing I can do is something like this. So I tried to do something, and I will show you what I've done. But I said it's called values. For people not so familiar with Red, I will do a quick overview of values. Nenad was talking about it in the morning. So let's imagine that you have some function. Let's call it add1. So this is very easy function that will add one. Nenad was talking that everything in Red is data until it's evaluated. So what does it mean? When you write this source code, it's 2, 4, 6, 8, maybe 20 characters. It's loaded as values. So this is one value, second, third, fourth value. These are blocks. So this block has 3 values. This block has 1 value. Each value has its own type. This is set word, this is word, block with word, block with 2 words, and 1 integer. This is how Red sees it, how it keeps in memory. So why the editor I'm working on, or the IDE I'm working on, is called values? Because I think that this is the level on which the editor should work. Not characters, but values. So when I take, let me show you how it looks. Try interpreter. It's very early stage, so it may crash. Yeah. So
that's what software demos are supposed to do.
Okay. VE is values editor. There are some other components, so I try to keep the names short. So I will make it bigger bit. Now you can see that the symbol, the prompt changed to arrows, so we are in the values editor, and as I said, it's line oriented, so I cannot write code directly. I have to run some specific commands, which I have written there. The commands are running some internal commands. One of the most interesting. So load. Okay. This command is prefixed with column, which is borrowed from Vim, which has column for some commands like file access. So I borrowed it from Vim. I think it's useful. Oh, does not exist. Okay, so I will put directly. So you see that the prompt uses some emoticons, emojis, because why not? It's 2018, it looks better. So script Red was loaded, 23 functions, 1 object, 2 code blocks. I will explain what does it mean. The script is now loaded, and the textual representation of the script isn't kept in memory. Yeah? Only the data are in memory. So this is very important. Command V is for view. VS is for view structure. So here is the structure. Again. Yeah.
So 1 and 2, these are code blocks. This is basically anything. Any code that is in the script is kept in the code blocks. Function definitions are here, shown specifically, and this is object. Yeah. So what does it mean? You know that the first code block, you read to some. The second code block defines some parse rules. Function shows number of requirements. Show founds as two arguments, name data, 3 requirements, 3 local values, and 25/130 values. Why there are 2 numbers? This is because blocks can have other values. So the first number is the flat length. If you call length on the block, this is what it will return. And the second value is total number of values in the source code. I can show you the F. It means the function. Then I can put space between the F and indent, but it's faster this way. So here is the specification for the function. Indent, insert indentation, modify. This is a health string. 1 argument value, 1 requirement that also has 1 argument. No locals, which is wrong because it should have 1 local, but it's actually working good, but I forgot to specify the indentation as local, so that's my fault. And 12/24 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so this is the top level, and if you count all the values, you will find that there's 24 of them. The code is colorized, so there's syntax highlighting, and as I said, it's loaded as data. So this is not how it was written in editor. There is some simple system that will put it on more lines, so it's not all in 1 line. You can see that, for example, here should be enter. It would look better if enter was here, yeah. But the system is very simple now, yeah. So it's actually 1 expression, second expression, third expression. So it should be turned into 3 lines. But this is something that is not implemented. But as you can see, the basic inserting of new lines works. The new lines are not kept anywhere in the data. They are shown only when displaying the code. So what is implemented right now? Implemented is basic search. I can search for new line. It will highlight all matches. Right now it highlights all matches because that's more important than highlighting just 1. I will add just 1 later. It's just a simple. Here you can see this block. It shows the marks. It's 11/2/1.
This means it's 11 value. In the 11 value, it's second value because 1, 2, and in this it's 1. So it's path to specific value. This is length. So I have selected one value. I can M is mark. C is clear. I remove the marks. I can mark. I don't know. First 3 values. Yeah, this works also. Okay, I put some other function there. I can search also by data type because, as I said, everything is kept as values, not as text. So I can search for example, for integers, and it will find all integers. You see that the search function is it doesn't search only on top level. It goes into all blocks. So clear it. I will find, I don't know, 1, and I can change it. For example, to 2. So basic editing functions you see work. Okay, what else is there? Yeah, okay. Because everything is everything is kept as values, I can do things like showing the type, but not type of the value, but not type of. Okay, let me start again. Lot of yeah. This may be. If I add % at the end, it will show some statistics. So there is 17 words, 3 blocks, 2 syllable, 1 integer, 1 character. So why I'm showing it is because this is typical. Most of the code is words, are words, and the words can have different value. It does not show. The statistics does not show types of the values of the words. Yet it can be added. But as you can see, the highlighting works. It actually checks for the value of the word. You can see that some words are white, not gray. White are functions, natives, operators, and actions. Yeah, so it checks for the type of value because it's word. This is word too, but it doesn't have any value. Yeah, it's unset. We can check it with annotations that will add. For every word, it will add. It will show a data type of its value. The type is right now the first letter of the type. So N is native, U is unset, action. Value is string. That's because it's leaking from somewhere. It shouldn't be string. It should be unset. So you have these annotations. I think that. Other stuff, not only type, can be added as annotation. Okay. The annotation off. Another useful thing for navigation is index. So you can see for every word is now prefixed with its index. Index is kept as path. This is one thing that I found very useful using using part that is full of numbers only. It's not supported. If you write code in Red, you can't do it. Yeah, you have to write the part. This command means execute something in Red. I have to write the part like this. 1, 2, 3. Okay, I have to write the part like this to get this, but it's actually very useful for working with nested code. And it would be more useful if things like add or pick or most actions supported it. Right now it's not supported, but if you want to work with nested code, you find it very useful. So I have functions like attendee, which means add deep, that accept this part.
Is the open parenthesis a special command in your editor, just before probe?
This open parenthesis means run it in Red console. Yeah. There is another one. Yeah, and if you have OCD, you can add.
That's why I noticed.
Yeah. Okay, there is another one which means run it in system shells. So you can call things in shells. So you can run basically anything. I have some macro system. Yeah, there are some macros. Macros are easy. Macros are started with hash because Red preprocessor uses issues as commands in preprocessor, so it does make sense to use hash. And I can show you macros. Yeah. I will turn off the indexes. Set some. This is macro replace speed because macros are executed very fast, but sometimes you don't run them fast. For example, for demonstration, so I will run this macro, which basically does navigation. Everything. Another macro, what I have, yes, what is also important in editor is to write comments, to comment the code, and because this is not text, this is just the representation of data in memory. We cannot use the standard way of writing comments, which is semicolon followed by some text. So my idea was to comment the values directly. Yeah? It's not supported in the editor yet. There is comment support but right now to add comment you need to modify the editor object directly. So I got this macro for it. C+ means add comment, which adds comment to this value, set indentation value defaulted for. And this is comment. When I want to save the data on the disk, this command will be added in typical normal way with semicolon, and then this closing block must be moved on another line, so it won't be part of command. but that's actually not implemented yet. Also, scanning comments in the source code isn't done yet, so it's only in memory right now. Some notes, but I can't read them. Yeah, okay. So that's basically what is implemented right now. Yeah, you can examine the structure of the script, which I showed you. Yes, show the structure. You can examine the functions, you can edit them, you can examine the object. Yeah, we chose objects, so basically same as showing function. Nothing much more is implemented. If you have any question, that's
cool. As you were doing the highlighting and the annotations, it just sparks so many thoughts about how this could all be used. We tend to think of, we're going to process large files and how much extra memory will this take. But when you start seeing how it could be useful, like the leaking value, that should not be a string. That's leaking from somewhere. You can instantly see things in different ways.
Yeah, I think that's a very, very important thing. Yeah, these annotations is extremely important. There's one thing that I've been thinking about. For example, this block, this one too, is parse rule. Yeah. So you can say that you can say to the editor, do not highlight this block according to standard code rules. Highlight it according to my specific rules, because it doesn't matter if it's unset or if it's character, yeah, or these are keywords in your parse rules. So they should use different rules for colorization. Yeah, that's something that I was thinking about. It's of course not implemented yet because this is very early demo. Yeah? But editing values and not the text. It really forces you to think about the source differently.
Yeah. But one of the other things, talking about why we don't have IDEs, we can do an IDE and use an external colorizing editor for red proper, for the main language. But as we get into dialects, suddenly it's how do I detect that I'm inside a dialect so I can make more sense of things? And tools like this will be great for experimenting. 2 questions. How long have you been working on this, and about how big is the code?
I've been working on this for a month, I think. Yeah, on and off. Of course, not fully, because I have a job.
What?
And and how big is the code? We can check it. You see that? Okay. So values is the main function. It's 20 kilobytes. Script is a lot of support functions. Some of them are from older version that can be removed. So it's 30 kilobytes. Help. This is text. There's no way to display the help. You can. I'm working on adding it, but it's not done yet. Colorize is only 6 kilobytes because. It's part by type. There's not much more to do. I think the biggest part is trying to guess when to insert the enter. Yeah, that's the biggest part. There are some macros, and that's all. Test tree, oh, this is nonsense. Yeah, this is something I'm trying on. So 40 kilobytes, I think.
That's great.
I have two questions and one comment.
Okay.
First question. Did you think about something, maybe annotation system or something for the binding, to show the binding of words?
Yeah. I've been thinking it's not done. I think I have some functions that should do it, but there's no way to display it. But it's something that's on my mind. Yeah.
Well, you don't have a lot of choices. Could be a color scheme, specific color scheme, or could be some extra characters, special Unicode characters to connect to the right context. And I'm not sure. But
what I've been thinking about is there's currently no cursor. Yeah, but the selection can basically work right cursor. So if you have only one value selected, this info line can show name of the value, its value, and its binding. Yeah, so this is possible. That we will show this info just for the selected value, so the user won't be overwhelmed with information.
Yeah, so actually here in this source code, the value with the S annotation is something that normal text editor cannot do, and that gives you the information that the value is leaking from global space.
Yes.
And it should be undefined there.
Yes.
So you have something global space that interact with that, and that's typically the kind of information you can't get in a normal editor.
Yeah, there are in the editor, in the values editor, there are some functions for making difference between words at the start of some action and words at the end of action. So you know what new words are there, and if something leaks and so on. Yeah, but it's not actually
something else we've talked about. Oh wait, go ahead and ask your other questions.
Did I miss it, or how do you edit code actually? So if you want to write some insert some values there, do you have to type some command, or do you have an interactive?
Yeah, you can. What I've been showing is that you can change values, and what I can't show you right now because it's not currently working. Okay, let me say it in another way. When you think of the source as data only, as a series, you have a lot of functions in Red that work with series, insert, append. So the editor will use these actions exclusively. Insert, append, clear, poke.
So you mean you don't have to type them? You just invoke them, or insert them inside the source code, right? As one keyword. You don't have to type INSERT.
Yeah, if let's say that I don't want the value, but I want to return value, so I would write E return. This is E is for insert, return is for the value that will be loaded. Yeah, this string will be loaded, and because it's Word, it will be inserted as Word.
So you operate on your line editor line, which turns it into values, which are then
yes
acted on the series.
This is loaded, and once it's loaded, it's only value. Yeah, no strings are kept anywhere. This dialect is of course not the only way you can interact with the core. Yeah. Of course, it can be turned into graphical editor with navigation, and actual inserting can be done with cursor here. Yeah. It's because I'm working in console and we don't have console port, so that's why I'm using this.
Just a comment. Have you looked into, so basically such kind of editor, the concept is called structured editors, and it's something that exists in the Lisp world. Some people have tried to build some structured editors for Lisp since a while. So I think you should have a look at these. I think on Wikipedia there's a page for that lists them all, and you can have a look and study the different approaches they are using for achieving the same kind of thing, where you modify directly the loaded S expression in memory, and you don't act on the text version of them, but directly on the structure loaded in memory. And have you looked also in subtext project? Maybe some good ideas there.
Jonathan Edwards.
Yes, but mostly, I think you should look at structured editors and just see what other people have built for Lisp languages for that. And there's another one for the Java language. Yeah, there's one for the Java language that I studied last year because I was interested also into seeing if it's possible to write a structured editor for Red. And I can't remember the name of that Java framework for that, but we have a full visual IDE for that. And so you edit the code by exactly like you do here. So you insert new blocks, and then you write there, and you nest blocks like that, and all the code that is shown in IDE is nested, and you navigate it using a tree. And so it's probably the most advanced structured editor I've seen so far. And so you should also have a look. I can find it and send you the link to that project.
There is something.
Yeah, because in case of Red, it makes sense also, like in Lisp languages, to have a structured editor, but it's pretty challenging to make something like that scalable, because it works very well in a short source code. As soon as you have a very long or very deeply nested source code, it becomes more challenging to make it keep it usable.
Yeah, but even if you have long source code, it still has some structure. You know, there are objects, so you will go to the deepest level, and even if this function will be in nested objects with I don't know.
So
path that has 5 values. Yeah, you will
are you thinking about like a tree structure that you can navigate and you can open?
There is tree structure of this.
You can fold and fold the different levels.
Yeah, you can see that it's word, it's action.
You can
the type of the value is action. Yeah, so we can show all the tree. I forgot about it.
So the point I was going to, or the question I was going to ask about showing bindings is, for those who are new to Red, one of the other things that trips people up or that they find different is we don't have parentheses around function arguments. We have what's called free-ranging evaluation, and that can make it a little more challenging when you're learning Red. How many arguments does this function take, and where does the next function call kick in, and how does that all work? Being able to show where those function calls actually go would be really, really cool.
Yeah, it's something I'm thinking about.
Okay.
So that's it.
Thank you. Thank you. I think we are about at the end of our reservation time, so we'll do our prize giveaways.
Nice call. Does anyone have any question about extra question about Red?
I saw intent hex format in source code.
Sorry,
intent hex.
The new hex data type.
No, it's S record, something like S record.
X data type.
Yeah. But it's not used in anywhere, I guess.
It's for Ethereum and the blockchains. So we are thinking about, well, it's based on the big number library that we have, but it's not in master branch. And we give it just X format because we want to have a first-class support for the addresses and the hashes in blockchain, so that in C3 we can express them directly using 0x and that format, and that the compiler can manipulate them and do maybe some operation on them. So we need that first-class support for that.
And,
because we want the C3 to be loadable.
How do you recognize if it's pair or
minimum 10 characters after the X. If it's less than 10, it's a pair, and we will pass it as a pair and output an error if it's wrong. It needs to be more than 10 characters after the X. But that fits well with Ethereum usage, so no problem with that. We don't know if we will integrate that as in the master branch, I mean in the core language, or if we will make that, keep that in a separate module that will be loaded only when you load C3. We're not sure yet.
So the modules can add new data types?
It's possible. We made some changes recently in the port type, I think, branch, to make it more easier to do that. So yes, it's possible. We haven't tried it yet, but I think Maxime did try, and they are using that already. So it's just about writing a new data type description using Red System and calling the data type register function, passing the block with all the actions there and the few parameters required for that, and that's all. We just have a problem with fixed type IDs currently, so
he just added.
We just need to change. I think we just need to change the register function to return the new incremented type ID. I think that's the only change we need to do to enable loading data types, adding new data types dynamically.
Okay. We do have a couple women's shirts. If anybody has a woman in their life that wants or doesn't mind a different style, if they want to take one to them. We have a hat we got from the Ethereum DevCon that's got a pretty nice little logo on it, and I can't remember what the company was, but it's all black if somebody likes baseball caps. So what we'll do here is draw numbers out of the bag, and I thought maybe we'd do a live coding, random number generator lottery demo, but we don't need to do that. There are few enough of us, and we're not going to wait for the blockchain to commit all those transactions to find out who won. And I think we've got a lot of gifts here because NANAD is excluded from participating. I think I'm pretty sure you don't get to win. You don't get to win a prize.
I can't take any.
No. We have some privacy and security oriented bags we thought would be good for the Ethereum DevCon theme. The pack-safe bags and the travel-on bags have mesh in the fabric, so they're slash-proof, and they've got it in the straps as well. We've got a little Victorinox travel bag, a little Leatherman squirt, and a mag light. So we'll go in order, we'll draw the numbers, and then we'll go in order of numbers who gets them, and whoever gets to go first gets their pick of the litter.
Yes, I know, and yes, that's the framework for. Yes, I know that. It's a nice framework because it generates the ID. You describe the DSL, and then it will generate you not only the compiler interpreter, but it should generate you the IDE also, or the IDE plugin.
Okay, you can have one.
No, it's okay.
No, you can have one.
No, it's
Here, this is yours.
No,
It's yours. I feel bad sometimes when I'm so mean to him.
Yeah,
Not all the time, just
I know,
sometimes.
it's a nice project and they sell it. There are many customers in industry. I don't know, are you using this product? And? Wow. But yes, it has really nice features. So?
I think Vladimir must have number one. He's smirking. He looks like he knows something.
No.
No. All right. Who has number one?
Number one.
Number one. Okay, take your pick. We've got a bigger bag, a shoulder bag, a smaller pouch. If you only have carry-on luggage, I don't recommend taking the Leatherman because it's got a knife in it, and they'll probably confiscate it. Or at least in the U.S. they would.
So if we have a high number, it means we pick up a small prize.
Oh, you're number 10. Oh, that's too bad. I think all the prizes are going to be gone by the time we get to you.
Okay, that's why you gave it to me.
It was a random chance. It was totally random. All right, good choice. That was a very good choice. Number 2.
Thank you. It's okay. You can take. You can take it.
Oh, come on.
Come on. You can take it. Any price. It's okay. It's okay.
You have to take one.
Yes,
because he doesn't have room in his luggage for anything else.
I cannot carry that bag. I don't have space anymore.
Number 3. Number 3.
This one also you can add.
Oh, okay. A little flashlight? You want just a little flashlight?
Maglite.
Maglite? LED maglite? You really don't want anything?
I don't know what it is.
Oh, it's just a flashlight. Tiny little flashlight.
Oh, I iPhone.
We thought about Swiss Army knives, and the multi-tool was our first idea because Red is so flexible, it does all these things. But then we thought it's almost a bad message because most multi-tools aren't really good at all the things they do. So we got separate little things in each of the bags, and if you look in your Red bag, there are little trinkets in there. So we got specialized tools that are good at one thing, and that's kind of the message of Red. You can have a lot of little tools, and each of them is good at one thing, really good at that one thing. Okay, number 4. Oh, I should have had headphones or something.
Or music instrument.
Yeah. Number 5.
Do we pick or there is number 5?
Not my phone. And not my laptop. Those are not on the list.
Get the hardware wallet.
Hey, where'd my electric key go? I think.
Isn't it wallet? No?
This is number 6, so number 7.
Okay.
You can take it out and look at it if you want.
So did you try to implement for Bitcoin that one?
We do have we do have in a branch, in the development branch, we have a Bitcoin connector for the wallet, and it works. It's just that the amount of code you need to write for that is very big, so we need first to get it reviewed and audited before putting it on the master branch.
Number 8.
I made it.
The prices are getting smaller. Okay, number 9.
You didn't have that the Rebel DevCon.
This is the only thing left. You know what we should have done? We should have started backwards, and when we got down to the higher numbers, you could steal a prize from somebody else. We'll do that next time.
What else do you have? That's all?
That's all. We do have some extra little key rings on the red bags. There's a little key ring that threads on, but we have some nicer ones that are used for aircraft flight checklists.
I have some small gifts also.
Ah, yes.
Now it's not Marvel Avengers related. So actually, when we finished the token sales early this year, we thought that it would be nice to to print in real some of these tokens for friends and for people interested to that. So we printed these red tokens, real ones, very expensive. No, I'm kidding. It's printed in China, so it's not very expensive. But they are pretty nice. So it's a small gift souvenir for this DevCon. So I should have almost enough for everyone.
You want a key ring?
Well, even if you don't.
Key ring?
Thanks.
Yeah. From the rebel command. That was contributing to the rebel one. Wow. And so yeah.
Key ring. Well, you can use it for anything. Then you just push it in to release it. Does anyone want the hat?